Let's dive into our second example of setting up and evaluating a triple integral. So I went ahead and started the picture, but I didn't finish it because I wanted to show you kind of the hard part. So I want to find the volume of the solid bounded by all of these things. So oops, I actually have a mistake here. I said y equals 0. I meant z equals 0. Okay, so z equals 0, that's going to be our floor since the other things are above that. X equals 0 is right here, so you've got to be above the xy plane. We want to be bounded by x equals 0. And then I'm not sure yet, are we going to be on this side or this side? Actually, I can tell we're going to be over here. But I wanted to start with the cylinder, z equals 4 minus y squared. You should recognize instantly this is some kind of a cylinder stretched along the x-axis because there's no x, right? And we shifted up 4, and then we have a parabola opening down, and so I get this parabolic cylinder stretch. Now it stretches this way too, but I stretched it this way just so you could see it, and then I want to show you kind of the tricky part of how to draw it. Next we have this plane. The most important place that you can draw this plane is in the xz plane. I should label my axes just to be clear here. In the xz plane. So I did that. When x is 0, z is 4. When z is 0, x is 4. And so that plane you just stretch along the y-axis. You can draw it over here somewhere if you want to. I'll draw it out of the way over here. And you just stretch it along the y-axis, and that's what we get. Hopefully that makes sense. Okay. Now it keeps going, but that's it. So then x equals 0 is going to be right here, this vertical plane, and then of course z equals 0 means we're up. So the question is, we have to actually intersect the green plane and this red cylinder. And so think with me, the red cylinder keeps coming and it hits the plane. And the key is it's going to hit the plane right away right here, but a lot longer down here. It's going to actually curl around like that. Does that make sense? So the way this thing ends up looking is something like this. It's going to hit and then come on down and around like that, and then come on down and around like that. And it's going to, this line right here of x equals 4 is going to be the cutoff. Whoops, I don't know what just happened. Sorry about that. So that is the solid that we want. Is actually quite a bit simpler than all this other stuff that I've drawn. I'm actually going to go in and erase a bunch of stuff. So let's make my eraser bigger, and we can erase. We don't need the cylinder back there. We don't need the plane. We're just going to erase a lot of this. And I'm left with this guy. This is my y-axis still. All right, so have a look at this one. Whoops, there's still some things in there to kill. Let's see if we can erase this. All this stuff actually can go away here as well. There we go. So let's see how we can do this. Well, we have to figure out how to cut it. And what I want you to see right now is why I'm going to pick the cut that I am. So I often start by thinking about a type 1. I want to cut vertically along the z-axis. But if I do that, look, here my roof is this plane. But if I cut over here, my roof is actually this cylinder, and that's a problem. I don't really want to deal with that. There are ways to deal with that. You can break it up and have the sum of two integrals. We don't really want to do that. We really prefer to keep this simple and straightforward. So the point is, type 1 is out. Now let's ask ourselves, what if I cut it as type 2, and I want to go cut along the x direction first? So remember, I'm doing my cutting the solid first. So here, if I go from x equals 0, that's this back plane, and I come out, I'm going to hit, everywhere I cut, I'm going to hit the green plane, x plus z equals 4. So type 2, you can see, is the way to go. I want to go from the back out to this front face, and this front face here actually lives on, let's shade it green, it lives on our plane like that. So that is how we're going to do it. We want to do it as type 2. We're going to go from the back of this guy out to the plane itself. So I need to project this thing into the YZ plane. Actually, though, you can see the projection there it is. Pretty easy projection to see. We'll go ahead and write it down. I really encourage you guys to be in the habit when you're setting up triple integrals to draw that region, draw the region of projection. So this is my z and my y-axis, and quite literally it's just the same paraboloid shifted up 4 and then opening down. So that's the region that I'm going to do the other two integrals over. All right, so here we go. So the volume that we want is going to be triple integral. Okay, I'm cutting, first cut always is in the solid. So I'm doing x first. So I'm going to have a 1 dx, and my x is going from 0, x equals 0, out to this plane. If you solve this equation for x, you get x equals 4 minus x. So x goes from 0, I said 4 minus x, I meant 4 minus z. X goes from 0 to 4 minus z. That's the first setup. Now you get to pick the next part, the next two, your choice. You can do dy dz or dz dy. You're going to look at this projection. I can tell you right away, I want to cut it vertically. So I want to go dy and then I want to go dz and then I want to go dy. So I'm going to cut this thing vertically along the z-axis. So next one is going to be dz and then dy. Z goes from 0 up to this equation. This equation is just 4 minus y squared. So z goes from 0 to 4 minus y squared, and then y goes, just solve z equals 0, and you get plus or minus 2. So y goes from minus 2 to 2. This one is much more straightforward to integrate than the last one. I'm actually not going to work it out for time's sake. These videos, I'm getting a lot of them in this section, but I would really encourage you, pause the video. You're going to integrate 1 and get x, plug in your bounds, integrate the z, and keep plugging in. And when you work it all out, you should get 128/5 as your answer. So strongly encourage you to pause and make that computation. All right, I'll end this one, and then we'll go to the next part in just a minute. When you're done working